Kanishka, we can start.
Okay. Hi, good evening, everyone. So, thank you for joining with the third workshop of the IEEE Electronics Society Generative AI Challenge 2025. We have already done 2 workshops, and this is the third one. We are planning to do 1 session more. And thank you all for joining for this session. Today's session is titled Crafting Success with Right Mix of Tools and Services for the Generative AI Project Development Cycle. We are happy to welcome Dr. Haritha Thilakarathne, and we are thankful for accepting our invite. Dr. Haritha is a cloud solution architect in AI at Microsoft. He's specializing in scalable and secure intelligent cloud architectures on Azure. He has a lot of experience in machine learning and deep learning. And also he was awarded the most valuable professional in AI by Microsoft for 8 consecutive times. And Dr. Haritha holds a PhD in deep learning, and he's actively contributing to the technical community through conferences, tech talks, meetups, and through his blog. So we are happy to welcome you, and the stage is yours, Dr. Haritha.
Thank you, Kanishka. It's my pleasure to be here and share my thoughts on artificial intelligence and large language models and whatnot, everything related to AI. So give me a second. I guess you guys can see my screen, right?
Yeah. Yes.
Cool. Right. Okay. So let's get started. So before moving for the session, so little bit of ground rules, not the ground rules, just some guidelines. I don't want this to be a simple lecture kind of stuff because I hate lectures too. So I would say let's go forward with kind of like a discussion. If you have any question, just ping on the chat. So we'll see how I can help with those things. If that question is taking some time, what we can do is we can keep that question for the end, or else I can help you out in offline. If that's not in my scope or like something that I don't know, like I'll happy to help with finding someone that who knows the thing. Cool. Let's move forward and see what's going on with here. So Kanishka did an introduction about me. Yes, I work for Microsoft as a cloud solution architect in AI. So I have been working in a machine learning and deep learning space for over 10 years now, mostly developing applications and making sure those applications are industry ready and working in the industry. So that's kind of like the background I'm having. So while the session is going on, I need to take a look on like how our audience is. If you get a chance, just ping whether you are a university undergrad or are you doing your master's, or what's your experience with machine learning. For an example, you can say student having, let me know your experience with AI, machine learning and all from 0 to 5. 0 means I know nothing, I'm new to the industry. 5 means you are an expert. So happy to see your comments on the chat. Let's start from there. Right. Okay. So we have people who are having very less experience. That's good. Like we can start from the beginning. What about others? 3. Okay. Yeah. That's a good number. So nice. We have some PhD students and we have some starters in machine learning and all. That's cool to know, because sometimes we'll say if you hear a term that's not that you haven't heard forever, like just ping me. So I'll try my best to explain that term for you. And if it is something we can Google out, so let's make it an interactive learning experience. So when it comes to computer science, we have seen a lot of diversion from the technologies that we have been using for the past years or the decades. We started with the client server architecture, where we are having a client and then we are having a server we just call through APIs or things like that. That was kind of like the client server architecture we had decades ago. Then the internet came out back in like 1991, I guess. So internet came out, and that was a huge shift on how we use computers. Internet became the main sensation of people of uh, using for getting information as well as news, and it moves for the work life as well. Then after that, the mobile and the cloud came into the picture, because the computers that we had in our childhood was pretty big. Sometimes, like in our ages, that was just sitting on a desk. But before that, it was more like a room full of equipments that we called as a computer. But then after that, we moved for the mobile, which the mobile phones that we have today is actually a pretty fast and powerful computer. And then we diverted into the cloud, and we started using cloud services as our main consumption of computing. Though with these stages, then we came into the fourth wave, I would say. It is AI. We are only like second or third year in that era, but we have seen an incredible set of innovations with the era of AI. So 2024 was all about AI to access the knowledge with ChatGPT and the things like Copilot, etc. And as we enter 2025, AI is quickly evolving to enable us to action knowledge with the help of agents. So everyone is talking about agents and the things like that. We'll see how this whole AI life cycle has came up, and what are the things that we have seen with Gen AI adoption and all. Before moving into Gen AI or the generative AI, I would like to give you a picture on where generative AI is sitting in all this machine learning or the deep learning area. If you call the term AI or artificial intelligence, to be honest, I would call the term is one of the most abused words in the English language at the moment, because everyone is using this word artificial intelligence to explain anything and everything that is related to computers, which is not true. So artificial intelligence is having the ability to build or produce machines or algorithms that which can take decisions or think as humans in the layman terms. So that was not a new thing. AI came back in like 1940s. The term came back in like 1940s. People are talking about Tin Man or the robots that we had in science fictions. People are thinking if we can build machines that they can think and take decisions as humans, that would be a win. So they started building some concepts around artificial intelligence, and they started building the things like Turing tests, the things like that. And then they realized in order to get these machines work or these algorithms work, they need to have a way to teach something into these algorithms. In order to teach algorithms, or same as the human is learning, they thought of, right, okay, we can teach the algorithms using data. If you want to interpret or find the patterns behind these data, we can use statistics. Backed by statistics and mathematics, the evolution of machine learning came in. So inside artificial intelligence, we developed another area called machine learning, where we learn the patterns and the relationships between the data using statistics and mathematics. So that is machine learning. AI is the big picture. Inside AI, we have machine learning. Inside machine learning, we have a separate component called deep learning or the deep neural networks, where we try to mimic how the human brain is working. We try to give a mathematical equation or a mathematical representation for the neurons that we have on the brain. It's kind of like the vanilla term that we can use there, but it's more complex than that when it comes to different layers, and deep neural networks came into the picture. So AI is the very big one. Inside AI, we have machine learning. Inside machine learning, we have deep learning. Inside deep learning came into the picture with the advancements of computing power that we got from GPUs as well as from cloud computing. And inside deep learning, we have a separate part or like a small portion called generative AI, which these chat GPTs or the GPT Llama models, the Gemini models, or the recent image generation models like DALL-E and all those sitting inside the Gen AI thing. So if you take AI, now you can imagine it in your brain. So inside AI, you have ML or machine learning. Inside ML, you have deep learning. Inside deep learning, you have generative AI. Right. So that's kind of like the picture I want to give for you in the beginning. So when it comes to the Gen AI or the generative AI adoption, in the beginning, it was more into summarization, Q&A kind of task. So it was more about like summarizing large amount of information for easier consumption kind of areas. It was not that complex. We were using this GPT-1 models, or maybe in some cases, the models like BERT, language models for doing these kind of tasks. Then it came up into another level with data-driven decisioning. That means we tried to incorporate that the data that we have in our data repositories into the power of LLMs or the power of large language models. That gave the second steps or the data-driven decisioning came up into the picture. After data-driven decisioning, that came up to the third layer, which is the personalization layer, which we use deep learning models or the LLMs in order to tailor interactions with individual information from the personalized outputs or the inputs that we have. It's more like the third layer we have, personalization. After personalization, now it goes for another level, automation. It's more like automating repetitive tasks and streamline to be more productive. You may have seen this thing coming up in the industry right now a lot, saying LLMs or the generative AI models can do automation and can do a lot of things without any human interventions. In a way, that's true, and in a way, that's false. So you need to have a human in the loop to make sure you have a balance on the decisions that you take. Plus, you have kind of like a human interventions to make sure the decision that the AI is taking or the Gen AI models are taking is correct and it's more ethical. Right. This is kind of like the $1,000,000 question. I know most of you guys came into here to got to know some about the tools or the infrastructure that you can use for Gen AI development. I would go from a point of an industrial engineer who's planning a Gen AI model, Gen AI based solution, or any solution for an organization. That may be a research project, or that may be an industrial project that have a better return on investment. Right. So this is the $1,000,000 question. Do we really need AI? So we'll say, uh, uh, just put a like hands up here. Anyone from the industry? Anyone working as software engineers, data scientists, data engineers, or business analysts, or anyone like that? No one? We have I got a hand for one PhD student previously. Any other PhD students or the research students here? Cool. So we have some research students. I guess that's the yes for research. Yes. Right. Okay. So we have people from data science background as well. Yeah. Right. So so why I said this is the $1,000,000 question is in some cases what I have seen, though we say we need AI for that, there's no actual need of using AI or the related technologies to solve that task, to be honest. So we'll say a customer comes to you, or maybe your supervisor or the research institute or the research funding body comes to you and say, we have this problem, we have this interesting problem, and we need to solve this thing using AI. So that's the main tagline they can use. The main question you need to ask from yourself, and after analyzing the question that you got, would be, uh, do we really need to use AI for doing this thing? Is that a task that we can solve without using AI or generative AI or any of these fancy sort of technologies? In some cases, I have seen these things can some of the problems that organizations are having can be solved without a zero use of AI or these machine learning models or the LLMs as such. That may be a simple data pipeline building, or maybe building a data lake, or maybe making sure your security infosec things are right. So those kind of scenarios. So the first question you need to ask before jumping into AI would be, do we really need to use AI for this particular solution? Right. We'll say you are 100% sure you need to use AI for this solution. Uh, so there's a question. Yes, that's definitely a good one, Stephen. It says, yeah, but you said about wrong definition of AI, and therefore the answer to your question will all depend on how the person answering this question defines AI. Exactly, yeah. In most of the cases, what I have seen is the understanding of people of AI is very different. Some people think AI is more like a genie. It can do anything and everything. And sometimes they think, all right, okay, if you push AI for this, that'll work. It doesn't happen like that. So we'll say you have 100% shot on. In this case, we need to use LLMs or any machine learning model or anything like that in order to solve this problem. Then the next part would be how to adapt this thing into your solution. Because in most of the industrial solutions or any research project, in most of the cases, AI is only a subcomponent. I'm saying in most of the cases. It might not be the case in some cases where AI is the major component, but most of in industrial use cases will say that's an app development kind of thing. AI is a subcomponent of that. Behind that, there's a lot of layers that goes between for the security and app innovation side, or maybe app development, and everything goes between those things. So in those cases, the first thing you need to do is planning a strategy on how you need to adopt AI and what should be the strategy that you can use. That strategy will cover what are the resources that we're going to allocate for building this thing, and what sort of tools and the architectures that we're going to use on these things. And at the end of the day, who's going to do these things? Do we have talent in order to do these things, or are we going to hire people from outside to do this thing? That goes on and on. Then after the strategy, you may have to go for AI plan. How are you going to plan out these steps? And then it goes for a step where you say, right, okay, in this stage, we have done our strategy part. We have a plan how we're going to implement this thing. And then we go for the AI ready step. Then it evolves for designing and governing part of the things. So before designing anything or before looking on implementing anything, do your strategy or the readiness or the AI foundations first. For an example, do you like if you coming from a cloud background, you may know whether that's going to be Azure or AWS or GCP, anything. In order to do any sort of AI or machine learning experiment, you need to spin up the set of resources. For an example, in Azure, you need to have something called Azure Machine Learning, or maybe something called Azure AI Foundry, which includes all the LLMs, or maybe in AWS space, you have to have this AWS Bedrock thing, or maybe we'll say it is GCP, you have their Vertex AI and all those solutions there. You need to spin up those resources, and you need to have a proper idea how these resources are going to manage, and how a S3 bucket is going to talk with your Bedrock environment in AWS. Those things need to be sorted out. So that's more like the AI readiness and foundation before developing anything. Because We'll say you start developing, and in the middle of development, you think, all right, okay, I need to spin up another cluster. Yes, that can be done, but that should be managed properly with a proper MLOps or LLM ops lifecycle. All these things need to come with a very good foundation of responsible AI principles. So I'm not going to talk a lot on responsible AI principles, but you can refer all those things from the link that I have put here. I'll try to share these slides with you too after the session. So you can take a look on responsible AI principles that we have when it comes to AI development lifecycle. Why I emphasizing responsible AI principles here is because of the regulations that we have with the governments as well as developers in order to use AI for the betterment of the society. Because that's kind of like a double-edged sword, I would say. In some cases, if you use that thing in a wrong way, that can make a lot of harm. So make sure you follow those responsible AI principles when you doing this adoption life cycle. Right. Another question. So I need to ask from you. Does anyone here have heard of the term CRISP DEM? So CRISP DEM. This term, CRISP DEM. Has anyone heard of this term? Yep. Cool. So CRISP DM stands for Cross Industry Standard Practice for Data Mining, as I remember. So CRISP DM is kind of like a practice we have in order to plan out how we implement a data mining or data science or machine learning or anything that is related to data and analytics. Same as that, AI is not a one-off thing. AI development is not a one-off thing. You need to look on different areas, and it's going to go in an iterative manner when it comes to the productionalizing the thing. So it starts in the ideating or the exploring life cycle. Then it goes for the building and augmentation. Then after doing the building and augmentation thing, you go for operationalizing thing where you prepare the app or anything that you develop for deployment. Then when the deployment has been done, when it is in the production, now you get the feedback from the users. You need to use those feedbacks in order to update your build as well as maybe to do a better ideation session again too. So this is kind of like an iterative life cycle. You can't just put a LLM, will say a chatbot into the production and say, right, okay, this is freezed. So you don't need to do any changes. That's not going to happen at all. Right. So the concepts that we have followed before, like I talked in the first half of this session, was all about how to ideate and what are the main questions that you should ask from yourself before getting into any project that involves AI or machine learning or deep learning as of such. Right. So let's move forward with the rest of the things. I said when it comes to AI solutions, most of the solutions we see only the top tier where we talk about LLMs or the machine learning models or the things like that. But it is not the case. It involves a lot of tools beneath that in order to get those platforms right. So most of the examples, sorry, I'm having here is from the Microsoft ecosystem or the Microsoft Azure ecosystem, but this can be adapted for other clouds as well, maybe AWS or GCP. That may be the same. The names might be changed a little, but most of the concepts may be same. So when it comes to AI innovation, there are many layers that we need to look on. That starts with this privacy and security concerns that we have on the very top bottom, which is very crucial when it comes to AI development lifecycle. Then it goes for data services. Data services means how you manage the data. For any AI application, data is the main important and the most crucial thing. That data can be structured or maybe unstructured, textual or picture data, or maybe video data, or anything that lays in between. So data services manages how your data pipelines goes in, how you manage your data lake, and all those things comes there. On top of that, we have the app services that talks with the data and your machine learning models and the things like that. That comes with how you're going to deploy these models. That comes with the containerizing, Kubernetes, and all those things in between. Then after that, on top of that, you have the AI services. When it comes to the AI services that you see at the market, there's a lot. You have Azure AI Foundry, or maybe Azure Machine Learning, which involves with all the machine learning development. In some cases, you may have seen Azure AI services or the cognitive services where you have the REST APIs just to caption an image kind of stuff. On top of that, you have the development tools that involves Copilot Studio, VS Code, GitHub Copilot, Cursor, and all those tools that we have right now for development. So all these components should come together in order to build a good AI solution. So all the AI tools and the services that we have in the market, this is kind of like a differentiation I see, can be grouped into three sections. The first section is the pre-built models. It's more like you go for a shop, get a good shirt or a good dress and just wear it. It's pre-made, pre-built. You need to do nothing. You just buy the thing and you wear it. That's the pre-built way of using AI services. The things like cognitive services or the AI APIs or the vision APIs or the things like that we have are the pre-built ones. You do not need to do anything. You don't need to train any model. You just call a REST API and it gives you the output. That's good. If it is solving your problem, that's all good and all okay to use that thing. Use the pre-built ones. We'll say that pre-built ones are not working for you, then you can go for customizing. Customizing means you get the pre-built one and do some customizations according to the need that you have, do the customizing and use that thing in your application. For an example, in Azure, we have a service called Azure Custom Vision. Let's say you need to build an image classifier for some case. You need to classify the typical traditional use case, cats and dogs. So you need to classify those cats and dogs. In that case, no need to build from the scratch. You have 1,000 images of cats, 1,000 images of dogs. You put for that custom vision, and then after that, train a model, deploy as an API, use that thing. No need to build from the beginning. No need for coding. Just use that model after customizing. That's the same with coding as well. Anyone here familiar with computer vision? Have done computer vision, some small experiments? Cool. So then you may have been familiar with the term resonate and all, right? We'll say you need to build a new like a classification, same as that, cats and dogs classification kind of thing. No need to build a CNN from the beginning. What you can do is you need to get just your ResNet and get a pre-trained network and do kind of like transfer learning and then customize for your need. That's all about customizing. We'll say all like the two steps that we talked about, pre-built ones or the customizing is not going to work for you, then you need to go from the scratch. You need to build from the beginning. But what I have seen from my experience over the years is most of the problems that we have, we'll say 80% or 85%, can be solved with pre-built models or maybe with the customized models. There's very less chance you have to go from the scratch. That's almost all with the things that we have seen in very edge cases or very specialized use cases. As I said previously, when it comes to the AI services or the things like that, there's a lot out there. We have content safety, we have translators, we have Azure AI Vision, and we have language. These things can do many things. For an example, we'll say you need to create a caption for an image. You can just give an image for a REST API and it will give a caption for you. Recently, I did a very pretty interesting experiment because LLMs can also do image captioning. You can put an image for your ChatGPT and say create a caption for that. But with the recent calculations for some industry I saw, getting those image captions using using a simple service like Azure AI Vision is far more cheaper, very cheaper than using a LLM. So we'll say this is kind of like a big application where you need to create captions every day. And that's going to cost a lot if you're going to use LLMs rather than using a service like AI Vision or some vision captioning service, which is pretty cheap, right? So these are the services that you need to explore before getting into LLMs or the things like that. The next one is going to be Azure ML or any machine learning platform you have on the cloud. We'll say you need to build a set of machine learning models and you don't have the computation power in your computer to do these calculations. We'll say that's going to be a deep learning model that you need to train, but you don't have an NVIDIA GPU to train the thing. In that case, definitely that's going to be something that you need to look on with Azure ML or something like that, which provides you the AI infrastructure, model management with ML flow kind of things. Right. So that's all about like the pre-built ones and all. So I haven't touched the LLM space yet. So the next one is going to be on LLMs. So this one, I just shared the decision tree on how to select services. This is specifically on Azure side, but happy to like get this thing and adapt for any other cloud framework too. It's more like when you have this AI use case, what sort of tools or services that you need to use? Because even in Azure, there's a lot of services that you can use, but you may wonder in which way we need to use these things and what should be the way that we need to manage these services as of such. So this link I'll share maybe on my I can, no, not from here. I'll try to share in the chat. So this is a very good place where you look on in which place you need to get the services in. Right. We talked about agents. So put your hands up, people who have used LLMs and do some developments with LLMs now. Be the quick hand. People who have done some sort of development with LLMs. No one? Right. Okay. So agents is kind of like a very fast term right now. People are, yeah, we have some people we are seeing all around the world. So when we go for the past, we have something called RPA or robotic process automation. We have set of rule-based agents to manage and automate a set of tasks. That is RPA. Then we came into traditional machine learning or ML, or then after that we came for reinforcement learning kind of scenarios. So in those cases, we were looking into more predictive approaches. Then it diverted into Gen AI. It got a very big diversion into Gen AI. And we started with LLM-based agents or the single agents, same as ChatGPT or the things like that. Then it went on for complex reasoning kind of things where we have the multi-agents. After the multi-agents, the next step is going to be more like self-replicating agents and the things like that, where the agents can create agents that can do the thing. This whole agent concept, you can think of as a production line or an office, where you have separate individuals who can do a specific task. For an example, in an office, there can be a researcher who do the research, and there can be a proofreader who do the proofreading kind of things. So that's kind of like the idea of the office. But in order to complete one particular big task, you need to combine the task that everyone is doing. That's going to be a multi-agent architecture or the multi-agent system where each individual is doing their own task, then combining it together to solve the big problem. That's kind of like a very vague description on how these multi-agent systems are working. Right. So agents can be started with a very simple thing. So I can see a question here saying how to verify the handoffs in multi-agent system Azure provides. Yes, it is. So I'll get this question, make sure that I answer for this question at the end, right? Uh, so then after that, as I said previously, agents can be very simple, that starting from retrieval, and then that can go for very higher levels with autonomous. And so what I have seen is in the simple ones, IT help desk agents or the project tracker agents can be known as very simple agents. When it comes to the advanced level of the agentic systems that we have seen, is that goes for sales order agents or testing kind of things, that we go for application testing. So that's more like advanced sort of things, right? So on Azure, how we going to use these things? There are two main I would say tools that we have on Azure in order to build agents or the LLM based applications. The first thing is called Copilot Studio, which is kind of like the basic step that you can use. For an example, I'm not going to go for the demos, but if you have a simple web URL and you need to build LLM powered RAG, kind of like a RAG based architecture on that, just need to put that URL in, and that will build the vector database for you and build the chatbot where you can integrate into your team's environment, or maybe for your Slack or anything like that. So that's Copilot Studio. And if you want to scale that, you want to build it with more sophisticated features, then the second step would be using Azure AI Foundry. In Azure AI Foundry, so it's not only going to be but it's not going to be only Azure services or Microsoft services. In Azure AI Foundry, you can find out, like I'll show you that thing. You can find out around 1800 plus models out there. All most of the open source models, even including DeepSeek, is included in Azure AI Foundry to be consumed as a user. Right. So as I said previously, Azure AI Foundry is kind of like the main uh, product that Microsoft is providing for agents or LLM based development. It comes mainly with Azure OpenAI models, or the OpenAI models come on top of Azure. Then as the vector database, they are using Azure AI Search as the main vector database. But we'll say you are more like a PostgreSQL guy. Yes, you can use PostgreSQL there. And then after that, in Azure AI Agent Service, which talks with the agents, that's where multi-agent system agent handoffs coming in, that Azure AI Agent Service. Then it comes with Azure AI Content Safety, where you manage the things with the responsible AI and the things related for that. Right. So as I said previously, AI Foundry comes with all the models. If you're going for LLM based development, that includes the Hugging Face or the models related for Meta, the Llama models, and all the things related for that. So that's the goodness with that. You can use any of those models without hassling with different providers and providing the industrial level of security and everything on top of Azure. Yeah, 1800 models on top of that. Right. And the next question, like in most of the cases, AI or the LLM use cases, what we have seen is developers ask, what is the right model to go with this? And what should be the model that we can use in this scenario? So I would say there's no golden truth saying for this particular problem, this is the model to use. There's no golden truth on that. That totally depends on your investment, how much of budget that you have, plus the other restrictions that you have within the model. And the next thing you need to do is you need to do a proper evaluation life cycle by comparing different models with your particular problem that you have on that. We'll say you need to do a summarization. I guess for a summarization of a small text, there's no need of putting a big model like GPT-4o on top of that. A small model, we'll say a small LLM, like SLM, like 5.3 or 5.4 will definitely work there. So no need of going for a big model to do a simple task like some summarization. But we'll say that's going to be a reasoning one. A small model like 5 model won't do reasoning in a good way. In that case, you may need to go for a model like GPT-4o1 or maybe a DeepSeek reasoning model or a thing like that. So make sure you select the model based on the need that you have, plus other constraints that you have within the application development. Most of the common barriers that we have seen within this LLM development is mostly with the infrastructure and the dependencies. Because we have seen when it comes to the infrastructure that applications are running in is not robust. You need to have a proper infrastructure setup, some good DevOps setup before moving into this like LLM or any AI sort of development. And the next thing is comparing the right models for you, another common barrier that we have seen within the AI development. And last but not least, security and privacy concerns. Because most of the organizations in Australia, as well as all around the world, are pretty much concerned about how their data is handled, where this data is going to handle. In Australia, in some organizations, they have rules saying our data should only sit within Australia, even for the REST APIs. You need to have like a way to track down where your data is going on. So in those cases, the cloud services like Azure, even for in some cases AWS, provide the region-based deployments for the models in order to make sure the data is not going uh, from from outside the country. Yeah, as I said previously, model benchmarking is another good thing that you need to do when it comes to LLM deployment. So the tools like Azure AI Foundry gives you the capability of doing the model benchmarking on the cloud without making a lot of hassle. Right. So the next big thing is about like what tools that we have seen in the industry. In most of the cases, I have seen people are using AI Foundry as the main service to develop their LLM-based applications. For answering this question as well as uh, using Azure AI agent service for LLM handoffs in multi-agent use cases. Autogen is kind of like a framework that came up from Microsoft as an open source one. And then after that, people adopted that thing to become one of the main frameworks of using and building multi-agentic systems. Then semantic kernel is also available as a main tool, what I have seen in the industry, which they use for developing multi-agent systems. So we have a question here asking what's the difference between deploying a GPT model via Azure and using OpenAI API directly? Yeah, okay. What's the benefit of deploying through Azure? That's like a very good question. Is the LLM deployed in a region-specific way? Not a region-specific way, but like the underlying architecture of LLM is not going to change at all when you deploy for a region, but that ensures your deployment is within a data center of that region. We'll say that's going to be in Australia East. The deployment is going to be happen within Australia East. So that's one security that Azure is providing when you deploy a GPT model with Azure rather than going with the OpenAI API. Another one would be on top of Azure, we have the content safety layer by default. That's we call as SFI or Secure Future Initiative. That means or the Secure First Initiative that we get the security first. That means you have in the LLM, you are prone to have prone to jailbreaks or any sort of ingestions and the things like that. That comes default with Azure. That's another security layer you add on top of the OpenAI thing. And the next thing is why using like another advantage that organizations are seeing within using Azure OpenAI rather than using OpenAI is the enterprise security that they are providing rather than relying on a third-party provider. Because we'll say the customer that we are dealing with, or the organization that we are dealing with Azure, they are very much reluctant to use other services in so cases. Is my data being sent to OpenAI when I use Azure? No, there's no data sending for OpenAI when you using Azure. It's more like no data has been sent, because that's going to be a REST API at the end. There's no there's only the usage data is sent, but there's an option within Azure, and also in OpenAI, I guess they have, you can even eliminate that function as well, to write how to eliminate the usage data as well. There's a function on that. Then we'll move forward with the main tools that you can use. I would say if you are starting in your journey with LLMs or the LLM building, I would say Agent Builder in Copilot would be the main thing that you can use. Most of the people use Copilot in the PCs. And then for makers or the business people or things like that, Copilot Studio would be a very friendly interface that you can use, where you have low code and no code kind of scenarios. Then if you want to go pro code and do more sophisticated development, then go for VS Code, AI Foundry, and GitHub Code First. Then that will give you more flexibility, I would say. Right. So this is just like a slide I put on. For users and organizations, always go with Copilot, and then business processes and automating the tasks like that. You can lead with Copilot Studio. If it is app innovation and making sure you have very sophisticated cycles going on, then definitely go with the AI Foundry. And the next stages, I'm going to skip a bit more because the time has goes on. So AI services and all these LLMs are changing a lot. So we are right now coming to the 4th month of 2025, and we have seen a lot changing, right? It all started with some government regulations came in, plus some of big investments coming from big giants like Project Stargate from Trump's administration, that came in to pump a lot of money into AI development and advancements of AI. There's some Cold War going on between some countries in order to make sure they are getting the lead of AI. So things going on. And rather than going on that pathway, most of the open source models, what I have seen is industrial giants also accepting that open source is the future to go in most of the cases. For an example, Microsoft loves open source, being a very big open source contributor. So we have accepted to get most of these models into our ecosystem as well. So a good example is having DeepSeek model on Azure. And another thing is with fine tuning. We have seen that different ways of fine tuning, recent RL based fine tuning or the direct preference optimizations kind of things are coming into Azure as well as into the LLM space, where we can see a big future on these things in the coming year. And as I said previously, the agentic services that comes with a full package that start with enterprise readiness and extensive ecosystem for tools and the model catalogs all together in one service. That's going to be a trend coming into the industry right now. If you want to build an agent without a very big coding experience or very big IT infrastructure, that is going to be enabled with that. Then after that, another good question: would these agents, as of today, build Uber or Airbnb functionally like applications? I'm not too sure about the question. Agents as of today build Uber or functional like app. Yes, that's as I see the question. There's a very famous saying that came recently from Satya. It says SaaS is going to be dead. So that was very controversial, saying SaaS is going to be this, like Uber or Airbnb is going to be like SaaS applications. But in the future, there may be, and there can be agents that do the functionality as Uber or Airbnb from your favorite chat application. That can be the future. And that definitely I see there's a very, very good avenue opening on that area. Another thing is, do a hands up for the people who know what RAG is. RAG, R-A-G. Yep, we have one. Yeah. RAG, or the retrieval augmented generation, is kind of like a main term that we have been using with LLMs for a while. It is more like using LLMs and your own data to answer a set of questions or get some information retrieval out of that. We have seen some of the pitfalls or some of the drawbacks of RAG when it comes to big documents or maybe big document databases. We have seen some pitfalls of that. So we have seen in the recent times, people are moving towards multiple architectures. One thing is Graph RAG. Graph RAG came up later last year, I guess, later last year or maybe the start of this year. GraphRag has been a proven thing, working well in most of the contexts where you have very complex documents and very long documents in order to, rather than using RAG. But there are some disadvantages in this approach as well. For an example, the retrieval time is much higher than using the typical RAG environment. So if you're interested in that, just read on those things. These are some new technologies coming in at the moment. And another one is CAG, or cache augmented generation. Another thing that came up with the higher availability of context window within the LLMs that we have. Right now, we have a lot of contextual window within our LLMs. In some cases, the context window we have within the recent models like GPT-4 or maybe the Gemini recent models are very big. That can even fit a book inside that. So that these techniques like CAG, approaches like CAG, get the advantage of that using the context, getting the context into the real-time data augmentation or the data retrieval kind of scenarios. It's a pretty interesting one. I have added the paper there. You can read that thing if you're interested. And there is a very like a popular term that came up recently, I would say, MCP, or the Model Context Protocol. It's kind of like a protocol Anthropic AI introduced. It's a common language that LLMs can talk to each other for different tools and services, because each of these agents are talking to different tools. The tools are diverse. The tool ecosystem is very big. So there should be a way to manage these messages coming on and off. So MCP is another big protocol or a concept that came recently. And I see within this year, there might be very big advancements in MCP or related technologies would come in. So GraphRag, CAG, or MCP is going to be kind of like a very interesting buzzwords coming in the next few months for the industry. Because, for example, this LLMs and all these Gen AI is changing a lot. It is changing in a phase saying like after 3 months, the technologies that you have used in your applications is going to be outdated. So make sure you keep yourself updated on those things. Last but not least, the other, like one of the main things that I will say is, don't reinvent the wheel. If there's something that there out in the industry, out in the research world that you can use for building your application, use that thing. And if it is not working, build on top of that. And even if it is not working, then go for building from the scratch. So don't go for reinventing the wheel. So that's kind of like the last message or the takeout that I want to tell you. Any questions? And also, if you have any data science, machine learning, or related questions, you can ping me on LinkedIn. So I have put my QR for the LinkedIn there. So you can ping me there. So this question, I have an AI agent capable of reasoning and planning sequences of tool or function. I want to test or benchmark this, but access data for testing. Right. I don't have access data for testing. What are the available methods for evaluation? How can I assess the quality of the action trajectories it generates? So this is kind of like a tricky one. So in this case, you don't have the data. So one good thing you can do, you can select like a very small uh, set of beta testers over the crowd that you can put your things in a beta production. Then after that, harvest the data from them, and then after do some manual evaluations on top of that. So that's one of the very popular ways people do evaluations on, rather than just relying on evaluating GPTs and all. Because what I have seen in some cases, they use for evaluation, they use, yeah, something use RLHF, something like that. So happy to take this question offline and have a chat on that, because this is a very interesting question to take on that.
There was one question that was previously asked on the chat. Did we answer it, Doctor?
It was on anything for handling
Yeah, I think.
agentic handoffs within.
Yeah, handoffs. Yeah,
Yeah, I think we answered on
yeah,
that. That's going to be Azure AI Agent Service. Yeah.
yeah.
Any other questions? Right. Okay. How do we keep updated in this Gen AI space? Any newsletters? I'm not biased, but I followed the Batch, one of the newsletters, and there's another thing called Bean and Bytes, another newsletter that I follow. And then I follow deeplearning.ai as well. So those are the main newsletters I would say that I can remember. Else that's going to be LinkedIn. And I haven't tried this thing, but I'm going to try this thing again. With X, you can have a thread going on with all the AI startups or the companies that doing the stuff and getting the updates from there. But yeah, that's it's pretty hard. I know it's pretty hard.
Does Azure has some solutions like especially for researchers or students which are less costly or like affordable solutions?
On Azure, they have Azure for students. I'm not too sure on like how that's working, but they have the student accelerator here in Australia. Microsoft Student Accelerator, ANZ, as I remember the name is that ANZ Student Accelerator. You can search that thing on LinkedIn, and that would be a good place to get started, I would say. Okay. Any reasons why top AI features from Azure coming too late to other regions than US? Yeah, obviously, yeah, that's something we always ask from our PG as well. So that's basically because of some of the resource constraints they are having. So most of the big customers are sitting on in the US, but we have like if there's a very pressing need from an enterprise customer, so we definitely work to get those things into Australia East or the region as well. But as you know, there are very big resource constraints when it comes to chips and all. Physical resource constraints, I would say. So that is something that we have to look on. Yeah, so yeah, Azure is providing like a good set of out-of-the-box solutions rather than building from the scratch. Well, I have seen very big production-grade industrial applications running that on Azure AI services without building anything from their in-house.
Okay, I think maybe we can take one more question and finish the session if anyone has something. Yeah, seems like we covered everything. Oh, one final question.
Yeah. How can I improve the agent's ability to plan and sequence or tool calls more effectively? Right. So this is going to be a more like a how we orchestrate the first step of agents. That always comes with a good set of prompts, plus how you going to reason out your problem is. So there are like what we have seen in most of the cases that comes up with how you manage the first prompt and how you going to chunk up your question. So in some cases, we have seen reasoning models works well in that first step, where you reason out and get a good set of procedures on how which tools need to be called, in which way these tools need to be called kind of step. And then after that, using structured outputs, another good thing that you can use within that agents in order to plan out how your function is going on. So yeah, happy to have a discussion around that. Meet Sam. Yeah, just ping me on LinkedIn, so we'll have a chat on that.
Okay. Okay then. Thank you, Dr. Haritha, for, I think the session was very valuable. We learned many things that we heard, many things that we haven't heard before. That was an excellent session. And we have one more session coming up next week. So we'll give all the details through our social media channels. Yeah. Anything to share, Haritha?
That's all. Thank you, Kanishka, and thank you, Lakshita, for inviting me for this awesome session. Just keep in touch. So if you need any help towards from our side, happy to help at any time. Happy learning.
Okay, thank you. And good night, everyone. Thank you for joining the session. See
Good
you.
night.